everyone, these are the operations with rational numbers guided notes. Let's get started. We are going to start with a review of adding and subtracting integers as well as fractions. Add or subtract to simplify the expressions below. So 3 minus 5, I can rewrite it as 3 plus negative 5, and that equals negative 2. Negative 4 minus 9 is the same as negative 4 plus negative 9, and that is negative 13. Negative 6 minus negative 2 is negative 6 plus 2, and that equals a negative 4. 3 plus negative 1 will be 2. 2/5 plus 4/5. My denominators are already the same, so I will add the numerators, and that gives me 6/5, which is the same as 1 and 1/5. 2/3 plus 1/6. We will get common denominators of a 6th, and then that will change to a 4 because I multiplied the numerator and the denominator by 2. So now it says 4/6 plus 1/6, and that is 5/6. 5/8 minus 2/8. My denominators are already the same, so I'm going to subtract the numerators, and that gives me 3/8. 1/3 minus 2/9. Let's get common denominators of a 9th, and that will be 3/9 because I multiplied the numerator and the denominator by 3. So I have 3/9 minus 2/9, and that is 1/9. Rational numbers are numbers that can be written as fractions. Decimals that terminate or repeat will be able to be written as fractions, as well as all whole numbers and integers. Are all integers rational numbers? Yes, all integers will be able to be written as fractions. Are all rational numbers integers? No. Remember that integers are positive and negative whole numbers. So negative 5, negative 4, negative 3. But like negative 1/2 is not an integer, but it is a rational number. Write 3 rational numbers that are not integers. So I just said negative 1/2, 2/10, or negative 5 1/2. Circle the 3 rational numbers that are equal. Cross out the rational number that is not equal. So this is negative 1/2, 1 divided by negative 2, negative 1 over negative 2, and negative 1/2. These are all negative 1/2. Negative 1 divided by negative 2, or negative 1 over negative 2, that actually will simplify to a positive 1/2. So it doesn't matter where your negative sign is, numerator, denominator, or out in front, it will mean the same thing. All rational numbers can be written as fractions. Many fractions you may already know their decimal form. Write the following fractions as decimals. So here are some common fractions, and you may already know the decimals. If you don't know how to figure out the decimals, because maybe you don't have it memorized, we will talk about that more later. So 1/2 can also be written as 5/10. 1/3 is 0.33 repeated, and that line over the 3 means that the 3 continues forever. 3/4 is 0.75 or 75 hundredths. 2/3 is 0.666 repeated forever, so we write that with 0.6 with the line over it. If you do not know the decimal form of a fraction, you can always use long division to determine the decimal. Let's use long division to determine the decimal form of the following fractions. So we have 6 over 25. So let's divide 6 divided by 25. 25 will not go into 6, so I need to add a 0, but let's add my decimal and write it straight up so I don't get confused that there's a decimal there. So 25 will go into 60 2 times. 25 times 2 is 50. Subtract 10 is less than 25. And I'm going to keep going because I don't have a remainder of 0 yet. So I'm going to bring down another 0. 25 will go into 100 4 times. 25 times 4 is 100. And that is a remainder of 0. So I am done dividing. So 6 divided by 25, or in decimal form, is the decimal 0.24. Now let's do 3 11ths. So we have 3 divided by 11. 11 will not go into 3. So we're going to add our decimal, put it up there, add a 0. 11 will go into 30 2 times. 11 times 2 is 22. Subtract 8. Bring down another 0. 11 will go into 8 7 times, and that would be 77. 80 minus 77 is 3. Bring down another 0. 11 goes into 30 twice. 11 times 2 is 22. Subtract 8. Bring down a 0. 11 will go into 87 times. If you notice here, this pattern is going to go on forever. I'm going to keep getting 2727. So that is my decimal form. That number will be a repeating decimal. So I'm going to write 0.27, and I'm going to write the 27 with the line over it. That means it will go 2727, etc. Practice. Convert the following fractions into decimals. All right, so we have 5 divided by 18. 18 will not go into 5, so I'm going to add my decimal, and in my quotient as well, add my 0. 18 goes into 50 twice. 18 times 2 is 36. Subtract, I get 14, bring down my 0. 18 goes into 147 times. 18 times 7 is 126. Subtract is 14. I'm going to keep going, bring down my 0. 18 goes into 147 times. If you can see what's going to happen, this pattern will keep repeating. So my decimal will be 0.27. Now I'm only going to write the line over 7 because only the 7 is repeating. So 0.27 repeat. 7 divided by 16. 7/16 is the same as 7 divided by 16. So 16 goes into 7 0 times. So I will add my decimal. 16 goes into 70 4 times. 16 times 4 is 64. 70 minus 64 is 6. Bring down my 0. 16 goes into 60 3 times. 16 times 3 is 48. Subtract is 12. 12 is less than 16. Bring down a 0. 16 goes into 127 times. 16 times 7 is 112. Subtract, I get 8. Bring down my 0. 16 goes into 8 5 times. 16 times 5 is 80, and then I get remainder 0. At that point, I can be done, and it's not repeating. So my decimal is 0.4375. All right, let's do 1 1/8. I know with my decimal, my ones digit will be a 1, so I only need to do 1 divided by 8 to figure out my decimal. 8 will not go into 1. I'm going to add my decimal. Also in my quotient, add my 0. 8 will go into 10 1 times. 8 times 1 is 8. Subtract, 10 minus 8 is 2. Bring down a 0. 8 will go into 22 times. 8 times 2 is 16. Subtract is 4. Bring down my 0. 8 goes into 40 5 times. 8 times 5 is 40. And then I have a remainder of 0. So 1 1/8 as a decimal is 1 point, and then my decimal, 1 2 5. Fraction 2 2/15. So my whole is 2. I just need to convert 2/15 into a decimal. So I will divide 2 divided by 15. 15 will not go into 2. I add my decimal. 15 goes into 21 time. 15 times 1 is 15. Subtract, I get 5. Bring down my 0. 15 goes into 50 3 times. 15 times 3 is 45. Subtract, I get 5. Bring down my 0. 15 goes into 53 times. So this pattern, again, is going to continue. So my decimal is 15.13, and then the 3 is repeating, so the line goes over the 3. Notice that all decimals converted from fractions end, what sometimes we say terminates, or eventually repeats. This is true of all rational numbers. The fractions, when converted to decimals, will always end, like you'll get a remainder of 0, or you'll start noticing repeating digits. Cross out the number that is not rational. All right, so we're just going to circle the ones that are rational first. So 3/4 is rational because it's a fraction. All fractions are rational. 0.5 is rational because it's a decimal that ends. It doesn't continue on forever. 2.3, again, it ends, so it's rational. 2/3 over here on the side is a fraction, so it's rational. This one right here, 0.112. See this line right here? That means that the 1, 2 is repeating. This number right here is not rational because it's not a fraction, it's not a decimal that ends, and it's not a decimal that repeats because it says ... and there's no repeating digits that are just going to continue on forever. Remember, when adding or subtracting fractions, the denominators need to be equal. Once the denominators are equal, you can add or subtract the numerators. Let's look at the problem 1/5 minus 3/5. The denominators are already equal. So now you need to simplify. So once the denominators are equal, I just need to simplify the numerators, which is 1 minus 3 equals -2. So 1/5 minus 3/5 is -2/5. -3/10 plus 1/5. First, let's rewrite the problem with common denominators. If you need to review how to find common denominators, you will find the least common multiple of the denominators. So my denominators are 5 and 10. So 5 is going to be 5 times 1. I'm just going to write multiples. 5 times 2, 5 times 3, 5 times 4. And I'm going to stop unless I need to keep going. We'll see. 10 times 1 is 10. 10 times 2 is 20. I'm going to stop right there because I already noticed a common multiple. That means my least common multiple is 10, and that will go in the denominator. This already has a denominator of 10, so that can stay as -3/10. This number right here does not have a denominator of 10. 5 times 2 is 10, so 1 times 2 is 2. So now my problem says -3/10 plus 2/10. Now that my denominators are equal, I need to simplify the numerators. So -3 plus 2 equals a -1. Therefore, -3/10 plus 1/5 is -1/4 plus a -5/12. Rewrite this problem with common denominators. So my denominators are 4 and 12. I can write multiples of 4, which would be 4, 8, 12, 16, 20. Multiples of 12 would be 12, 24. I'm going to stop because I notice a common multiple of 12. So my denominator will be 12. My second fraction is already written with a denominator of 12, so that will not change. My first fraction has a denominator of 4, and it needs to change to 12. So 4 times what is 12? 4 times 3 is 12. So I'm going to multiply the numerators and the denominators by 3. So 3 times 1 is 3, and then 3 times 4 is 12. So now my denominators are equal, and I can simplify my numerators. So my numerators now say -3 plus a -5. -3 plus -5 equals a -8. So I'm going to write that in my numerator, and then my denominator is 12. So it says -8/12. Now I can simplify that because I can divide both of those numbers by 4. -8 divided by 4 is a -2, and -12 divided by 4 is 3. So that simplifies to 2/3. Add or subtract the following rational numbers. My first one, my denominators are already equal. I have fifths here on the bottom. So let's simplify my numerators. So it says -2 minus 4, which is the same as -2 plus -4, which equals a -6, and my denominator stays the same, -6/5, which is also the same as -1 and 1/5. -1/10 plus 3/5. My denominators are not equal. The least common multiple between 10 and 5 is 10. My first fraction already has a denominator of 10. My second fraction, I need to multiply by 2. So 5 times 2 is 10, and 3 times 2 is 6. So now I need to simplify my numerators. Negative 1 plus 6 is 5 tenths. 5 tenths simplified, that will equal 1/2. 1/2 minus 5/6. My common multiple will be 6, so I'm going to write those in the denominator. 2 times 3 is 6, so 1 times 3 is 3, and then this will stay 5 because it's already 5/6. Now I'm going to simplify my numerator. So 3 minus 5 equals a negative 2. So I have a negative 2/6, and that simplifies to negative 1/3 by dividing each of those by 2. 2/3 plus a negative 3/4. My common multiple of those is 12. 3 times 4 is 12, so 2 times 4 is 8. 4 times 3 is 12, so negative 3 times 3 is a negative 9. 8 plus negative 9 equals a negative 1/12. Simplify the following expressions. This first table is a bit of review. So remember, when I'm multiplying or dividing fractions, if I have one negative or an odd number of negatives, then my answer will be negative. If I have an even number of negatives or two number of negatives, then my answer will be positive. 4 times a negative 5 is negative 20. Negative 4 times a negative 5 is 20. Negative 3 divided by 6 is negative 5. Negative 30 divided by negative 6 will be a negative 5. So quick review, I have one negative, so it's going to be negative. Two negatives, going to be positive. One negative will be negative. Here I have 1, 2, 3 negatives, which is odd, so it will be negative. Simplifying fractions, when I multiply across. So 2 times 1 is 2, 5 times 4 is 20, and then that reduces to 1/10. I'm going to jump down and multiply these fractions here in the third row. 5 times 1 is 5, 8 times 2 is 16, and that is reduced. Now, depending how you learned how to divide fractions, I will do it both ways. If you learn to multiply by the reciprocal, it's going to be 2/3 times 6 over 1, and that will give you 12 over 3, which reduces to 4, and then 1/3 divided by 2/9, so keep, and then multiply by the reciprocal. So 1 times 9 is 9, 3 times 2 is 6, 9/6 is the same as 1 and 3/6, which is the same as 1 and 1/2. Now, if you learn to divide fractions using common denominators, let's do that as well. So the common denominator between 3 and 6 is 6. So the first fraction will change to 4/6, and then divided by 1/6. So 4 divided by 1 is 4. 1/3 divided by 2/9. My common multiple is 9, so that will be in the denominator. 1/3 will be 3/9, so 3/9 divided by 2/9. So my answer will be 3/2, which is the same as 1 and 1/2, because 3 divided by 2 is 3/2. To multiply or divide fractions with negatives, follow the normal procedure of multiplying and dividing and then determine the sign. So we have negative 5/8 times 1/2. We're just going to ignore this negative for a second. So we're going to multiply 5/8 times 1/2, which is 5/16. And now we're going to determine the sign. The sign will be negative because there is only one negative in the question right there, or an odd number of negatives. So a negative times a positive will give you a negative answer. So negative 5/8 times 1/2 is a negative 5/16. The sign for negative 5/8 times a negative 1/2 will be positive because there are two negatives. So a negative times a negative is a positive. So negative 5/8 times a negative 1/2 will be a positive 5/16. Challenge. The sign for negative 5/8 times a negative 1 over negative 2. So we already know 5/8 times 1/2, but let's look at our negatives. So I have 1, 2, 3 negatives. So 3 negatives is odd, so the answer will be negative. So it's going to be a negative 5/16. Dividing positive and negative fractions is the same concept as multiplying. Find the quotient of the fractions, then determine the sign. Practice. Calculate the product or quotient of the following rational numbers. So we're going to ignore the signs for a second. We have 2/5 times 4/5. So multiplying across, I get 8/25. I have 1 negative, so my answer will have 1 negative, negative 8/25. Let's do this one below. Negative 1/2 times negative 5/6, multiplying across. 1 times 5 is 5. 2 times 6 is 12. I have 2 negatives, which is even, so my answer will be positive. I can just leave it as 5/12. Negative 1/10 divided by negative 3/5. I'm going to use the multiplying by the reciprocal method, but if you use the common denominator method, you'll get the same answer. So we're just going to do 1/10 multiplied by 5/3, and that will give me 5/30, which reduces, I can divide the numerator and the denominator by 5, so that will reduce to 1/6. Now let's go back and figure out my sign. I have a negative here and a negative here, which is even, so my answer will be positive. Positive 1/6. 2/3 divided by negative 3/4, so let's divide it. So 2/3 multiplied by 4/3, ignoring my signs for a second, multiplying across, I get 8/9. Go back, look at my sign. I have 1 negative right there, so my answer will have 1 negative, negative 8/9. When adding or subtracting integers, you should have recognized that if the signs are the same of the two integers, then the result will be the sum of the absolute value of the numbers and the same sign as the integers. It will help to circle signs here. So if I have a negative 3, negative 5, notice those are both negative. Negative 2, negative 8, both negative. 3 and 5, both positive. Negative 2 and negative 3, those are both negative. So negative 3 and negative 5 will be a negative 8. Negative 2 and a negative 8 is going to be a negative 10. 3 plus 5 will be 8, because positive 3, positive 5, positive 8. Negative 10 and then a negative 3 is going to give you a negative 13. So back to what this was saying, when adding and subtracting integers, you should have recognized that if the signs are the same of the two integers, so see how these signs are the same here, then the result will be the sum of the absolute value of the numbers and the same sign as the number. So I can add the two numbers and keep my sign. Add the two numbers and keep my sign. Add the two numbers, keep the sign. Add the two numbers, keep the sign. Now we will extend our knowledge of integers to decimals. Look at the problems below. Notice the signs of the two integers in each problem are the same. Therefore, let's ignore the signs, find the sum of the numbers, and then place the correct sign. Remember to line up the decimals. So again, notice right here that these signs right here are the same. So negative 2.4 minus 6.53. So my sign will still be negative. So let's add 2.4 and 6.53, and then we will go back and add our sign. I gotta line up my decimals, add those. I'm gonna add an extra 0 right there as a placeholder. So I get 3, 9, and 8. So my answer is gonna be a negative 8.93. I have a positive 8.1, positive 2.61, so my answer is still going to be positive. Let's line up my decimals. 8.1 and 2.61, add a 0 as a placeholder. Add those together, I get 1, 7, and 10. And my answer is still going to be positive, so I'm just going to write 10.71. Negative 3.56, and then making it more negative by doing a 9.2. So my answer is still going to be negative. Let's add those together, and then I'll go back and add my negative sign, lining up the decimals and adding this 0 as a placeholder, adding those. So I get 6, 7, and 12. So my answer is a negative 12.76. Remember, even though my answer is negative and it's minusing, I'm making the answer more negative, so I still need to find the sum of those numbers and then go back and add my negative sign. Now let's look when the signs are different. Recall with integers that if the signs are different, then you subtract, and the sign of the solution is the same as the sign of the largest absolute value. Okay, so let's look at this table below. It says the sign of the largest absolute value. So I'm looking at these numbers right here, 3 and negative 5. So if they were both positive, 5 would be the biggest number. So since that's a negative in the question, the answer will be negative. If I'm looking at -3 and a +5, now that 5, which has the largest absolute value, will be positive. -8 and a +2. So both absolute values, 8 and 2. My -8 will be negative. And then 8 and -2. My 8 has the largest absolute value and it will be positive. So now I find the difference of the two numbers. The difference between 3 and 5 is 2. So then it's going to be -2. The difference between 3 and 5, again, is 2, but it's going to be a +2. The difference between 8 and 2 is 6, but it's going to be a -6. The difference between 8 and 2 again is 6, and this time it will be a +6. Apply the same reasoning with all rational numbers. So if I'm looking at 3.61 and this 5.9, 5.9 would be bigger. The sign of 5.9 in the problem is negative, so my answer will be negative. Looking at this, just the positive part, 2.1 and 8.3. 8.3 is bigger. 8.3 has a positive sign in the problem, so my answer will be positive. 6.25 and 1.3. 6.25 is bigger. 6.25 is negative in the problem, so my answer will be negative. 10 and 8.2. 10 is bigger and 10 is positive in the question, so my answer will be positive. Now I need to find the difference between the two numbers. So I'm just going to take largest minus smallest as positive numbers. So 5.9 minus 3.61. I'm just ignoring my signs, subtracting the largest minus the smallest as far as ignoring the signs, and then I'll go back and add my sign. So add a placeholder there. So subtracting gives me 9, 2, and 2. And my answer will be negative. So it's going to be a negative 2.29. So 8.3, ignoring my signs, just subtract them. 8.3 minus 2.1. Remember to line up your decimals. So 6.2, my answer is positive. Subtract the largest minus the smallest, ignoring the signs. 6.25 and 1.3. We'll subtract them. Add that as a placeholder. I get 5, 9, and 4. And my answer already decided is negative. So negative 4.95. Last one, 10 and 8.2. Remember to line up your decimals. Add that as a placeholder. So this will give me 8 and then 1. And my answer is positive. So 1.8. Quick tip. If the problem is subtracting a negative, like 6.2 minus a negative 4.3, then switch it to addition by adding the opposite. So 6.3 minus a negative 4.3 will become 6.3. Then you're going to add the opposite of a negative 4.3, which is 4.3. And then you can add 6.3 plus 4.3, and that will give you 10.6. So let's practice doing that here. A negative 1.2 minus a negative 3 is a negative 1.2 plus 3, and 4 minus a negative 1.5 is 4 plus 1.5. Now let's do this one right here first. My signs are the same. I can just simply add those numbers. 4 plus 1.5, and that will give me 5.5. This problem right here, I noticed that I have a 1.2 and a 3. The 3 has a larger value, which is positive. So my solution will be positive. Then I'm just going to find the difference of the two numbers. 3 minus 1.2, add my 0 there. And that will give me 1.8, and it's going to be positive. Explain in your own words how to add or subtract decimals if the signs are the same. So this is what I wrote. If you have a different way of explaining it, as long as it's accurate, please do that. So you're going to sum the absolute values of the integers. So when I say the absolute values of the integers, I'm just saying pretend the integers are all positive. So sum them all together, then go back and add the sign, which is the same sign as the integers in the problem. So quick reminder, if it was negative 2 minus 6, 2 plus 6 is 8, and then I have negatives, so it's that. Or if I have 2 plus 6, obviously, then they're both positive, it's just going to be 8. Explain in your own words how to add, subtract decimals if the signs are different. So you're going to find the difference of the absolute value of the integers. Or in other words, you are going to pretend that the decimals are all positive and you're just going to take the largest minus the smallest, assuming they were all positive. And that's what I mean by absolute value. Then go back and add the sign, which is the same sign as the integer with the largest absolute value. So if it was positive, which one is the largest, and use that sign. So for example, if I have -2 plus 6, and I'm just going to subtract 6 and 2, which is 4, and then 6 has the largest value there, so it's still going to be positive. Whereas if I had 2 minus 6, again, I'm just going to do 6 take away 2, which is 4. But here, 6 is still the largest value, but now it's a negative, so that would be a -4. Rational numbers are used often in the real world. Let's look at the following situations. Shane is in debt $4.50 in his bank account. He then deposits $20 into his account. When someone is in debt, we can represent this with a negative. To determine the amount in his account after his deposit, we need to determine -4.50 plus $20. So we need to find that. Now I look at these and I notice this one's positive, this one's negative. So I'm simply going to subtract them. I'm going to go 20 minus 4.5, lining up my decimals, and that will give me 15.5. And since 20 is bigger than 4.5 and 20 is positive, my solution will be positive. So it's going to be $15.50. The submarine descended 1 2/3 miles every 5 minutes. When a person or object is below sea level, we can represent this with a negative sign. We want to determine how far the submarine has descended in 1 hour. First, let's determine how many sets of 5 minutes are in 1 hour or 60 minutes. And that is because in the question it's giving me minutes, and then it's also asking me in hours. So I need to convert those. So I'm going to figure out how many times is 5 minutes in 1 hour, and that's going to be 12. I figured that out because 1 hour is 60 minutes. So 60 divided by 5 equals 12. So the submarine will be descending 12 times in 60 minutes or 1 hour. So how could I represent this accurately? Which one of these is going to represent the situation? Well, if it is descending 1 2/3 miles, that's going to be a negative. So it needs to be a -1 2/3. That means I can eliminate this one and I can eliminate this one. It's happening 12 times. It's not a -12 times. Time is going to be positive. So my 12 will need to be positive. That means -1 2/3 times 12 will accurately depict the situation. So now it's asking us how far does the submarine travel in 1 hour. So let's multiply. So it's descending 1 2/3 miles 12 times in an hour. So we're going to multiply 1 2/3 times 12. So we have 1 2/3, and I am going to change that to a mixed fraction first. So 3 times 1 is 3, plus 2 is, so that's going to be 5/3. And I am multiplying that by 12, or 12 over 1. 5 times 12 is 60. 3 times 1 is 3. 60 divided by 3 is 20. So the question says, how far does the submarine travel in 1 hour? Well, it travels 20 miles. Why should we not depict 12 with the negative sign? Well, the 12 is representing time, and time is always moving forward, and therefore it will be positive. In real-world problems, you may see different forms of rational numbers. One strategy is to convert all numbers to the same form. So you can convert them to all fractions or to all decimals. Let's look at this question. It says, example, Dave spent $3.90 on 3 1/4 pound of potatoes. Determine the cost of a pound of potatoes. You can either convert $3.90 to a fraction or 3 1/4 to a decimal. Let's choose to convert 3 1/4 to a decimal. I know that 1/4 is 0.25, so 3 1/4 is going to be 3.25. Write the division problem to determine the cost of a pound of potatoes. So if he spent $3.90 on 3.25 pounds of potatoes, and I want to figure out the cost of 1 pound of potatoes, I'm going to take 3.90 and divide it by 3.25. So let's figure that out. 3.9 divided by 3.25. Move my decimal over twice, move it over twice, bring it up. 325 goes into 390 one time, which is 325, and then I subtract, which is 65, bring down a 0. 325 goes into 650 two times, and that's 650 with remainder of 0. So it will cost $1.20 per pound of potatoes. Practice. Sarah ran 1.2 miles, which was 2/5 of her distance the day before. How far did she run yesterday? So I have a decimal, I have a fraction. Let's change this fraction into a decimal. I can do that by dividing. 2 divided by 5. So let's add my decimal and add my 0. 5 goes into 20 4 times, which is 20, and remainder 0. So instead of 2/5, I'm going to write 0.4. Sarah ran 1.2 miles, which was 4/10 of her distance the day before. How far did she run yesterday? So Sarah ran 1.2 miles, and that was 4/10 of her distance. We'll use D for distance yesterday. So now I can divide both sides by 4/10. 1.2 divided by 0.4. If you don't know what that is, I can do it off to the side. 1.2 divided by 0.4. Move my decimal over once on both of them and bring it up. So 4 will go into 12 3 times, and that's 12 and remainder 0. So yesterday she ran 3 miles. Okay, everybody, that's it for today. Thank you.